Hello everybody, this is Dr. Samuel here again, and in this video we continue looking at the 2021 Caribbean Secondary Education Certificate Examination in Mathematics, and that is paper 2. So we are on question number 9, and the question is on circle geometry. Now, in any geometry question, you are required to remember the basic geometrical rules. So as we go through this question, I'll explain to you the rules that will allow you to answer the question. So the question reads, in the diagram below, E, C, G, and F are points on the circumference of a circle. So E, C, G, and F, E, C, G, and F are the points on the circumference. The tangent AEB is parallel to CD. AEB is here. It's a tangent because it cuts the circle at one point only. In fact, it touches the circle, not cuts, touches. And it is parallel to CD, which means these two lines point in the same direction. They will never meet, no matter how far you produce it in a straight line. And you're given some angles. Angle AEC is 68 degrees, that's down here. And angle EFD is 106 degrees, that is up here. The first question, you have to determine the value of the angle ECD. Now in circle geometry, in fact in any geometry question, you must ensure you give your reason for your answer. So let us look at where angle ECD is. E, C, and D is over here. So therefore angle ECD is this angle right here. So we have to figure out, based on the angles we have, which rule or which geometrical rule will allow us to find the angle we want. So if we look closely, we're going to see that based on the parallel lines AB and CD, we have what we call alternate angles. Angle AEC is alternate to angle ECD. You may also call it Z angles in parallel lines. And the rule is that alternate angles in parallel lines are equal. So therefore, angle ECD is 68 degrees, the same as angle AEC. So let's write it. 68 degrees. And we'll put the answer down here and we'll give the reason. So this is the reason. Angle ECD is equal to angle AEC, and the reason, alternate angles. So we have our first question answered. Let us go to the second question. The second question is to find angle CEG. So we go back to our diagram and locate angle CEG. Angle C is here, angle E is down here, and angle G is up here. So this is the angle we want. The point C is here, E is down here, and G is up here. So this is the angle we want, CEG. So what rule can we use to find that angle? There's a basic rule concerning the tangent to a circle and the diameter or radius at the point where the tangent cuts the circle. The rule simply states that the angle between a tangent and a radius is 90 degrees. So therefore angle AEO is 90 degrees, and since angle AEC is 68, then angle CEG is 90 minus 68, which is 22 degrees. So this angle here is 22 degrees. So we go and write out the answer and the reason. So the reason, angle AEO equals 90 degrees, and the reason, angle between a tangent and a radius. So if we go back, we'll see it. Angle between a tangent, that's AE, and a radius, that's EO, is 90 degrees. And therefore, angle CEG is 90 minus 68, which is 22 degrees. As shown in the diagram, we subtract the 68 from the 90 to get 22 degrees. So let's go to the next question. So in part 3, we have to find angle CGF. So we go back to the diagram and find out where this angle is. And angle CGF is this angle up here. So we have to figure out the rule we can use now to find angle CGF. Now you'll realize we have a quadrilateral inscribed in the circle. The quadrilateral is ECGF. And there is a rule that anytime you have a quadrilateral inscribed in a circle, like this one, it is called a cyclic quadrilateral. And the rule is that the opposite angles of any cyclic quadrilateral add up to 180 degrees. And so therefore, angle CGF, which we want to find, plus this angle opposite to it, which is angle CEF, supposed to add up to 180 degrees. And therefore, if we can find this angle, which is angle GEF, we can add it to 22 degrees to find this angle here. And then we'll subtract it from 180 to find the angle we want. So let us see how can we find this angle right here, angle GEF. Now, remember there are different ways you may use to find any answer. But one way I'm seeing right now is that we can find this angle here. Because this angle here plus the angle up here, these two angles are what we call co-interior angles of parallel lines. And co-interior angles of parallel lines add up to 180 degrees. So we can find this angle here by subtracting 180 minus 106. And we're going to get 74 degrees. So this angle is 74 degrees because of the rule about co-interior angles. The first part, and therefore this angle here is 90 minus 74, which is 16 degrees. And remember the reason? The angle between a tangent and a radius is 90 degrees. So angle OEB is 90, and therefore angle OEF is 90 minus 74, which is 16 degrees. So So this total angle here will be 22 plus 16, which is 38 degrees. And so the angle opposite is 180 minus 38 degrees. And that is 142 degrees. So this whole angle here is 142 degrees, which is what we want. So let us now write the answer. We write out all the steps we took to get to the answer. So first, the reason angle BEF is 180 minus 106, which is 74 degrees. Let me show it to you again. Angle BEF, which is this angle here, is 180 minus 106, which is 74 degrees. And the reason these two angles add up to 180 degrees because they are co-interior angles. That's the first step. Second step, angle BEO is 90 minus 74, which is 16 degrees. And angle BEO is this angle right here. It's 90 minus 74, which is 16 degrees. And the reason that's 90, we saw already, because the angle between the tangent and the radius is 90 degrees. The third step is this whole angle here, angle CEF, is 22 plus 16, that's 38 degrees. So I've written it down here. Angle CEF is 22 plus 16, that's 38 degrees. And finally, since angle CEF is the opposite angle in the cyclic quadrilateral to what we want to find, CGF, therefore angle CGF is 180 minus 38, which is 142 degrees. So back to the diagram. Angle CGF is the opposite angle in the cyclic quadrilateral to angle CEO. It's angle CEF, sorry, which is 38 degrees. So this angle here is 180 minus 38, which is 142 degrees. And that's it for that question. However, I do see a problem in the sum. In that, remember I told you you have more than one way to do a sum. There is another rule in geometry that says the angle between a tangent and a chord. So look at the tangent BE and the chord EF, which is 74 degrees. The angle between the tangent and the chord is equal to the angle in the alternate segment, which is ECF. But obviously in the sum they are not equal. Okay, so if you do the sum that way, then you may get a different answer, and I guess you will still get it correct. So there is a slight problem in the sum. So that is it. I will see you next time. We'll move on to the second part of the sum, which is on bearings. If you like this video, then you can subscribe or share. See you next time.